You know, every time you get clean water from your tap, you're part of this massive, invisible system. But have you ever stopped to wonder what happens to all the gunk that gets taken out to make that water clean? Well, that stuff is called sludge, and its journey from being a watery problem to a potential resource is one of the coolest stories in environmental engineering. So let's follow that journey together. Here's the game plan for our deep dive today. We're going to start by really getting a handle on the sludge problem itself. Then we'll walk through the main treatment stages, thickening it up, letting microbes digest it, and then squeezing all the water out. And finally, we'll see where it all ends up. All right, first things first, we need to understand the scale of what we're dealing with. So what exactly is sludge? And why is it such a headache to manage? I mean, it's a pretty straightforward question, right? All those solids, both organic and inorganic, that we filter and scrape out of our wastewater, they have to go somewhere. They don't just, vanish into thin air. And that somewhere is into a material we call sludge. It's basically the concentrated leftovers from the whole water cleanup process. But that term semi-solid, it's a little misleading because the real challenge isn't the solid stuff itself, it's the insane amount of water that's mixed in with it. And this number is everything. Over 95%. Just try to picture that. Imagine a huge tanker truck full of sludge. Almost that entire truck is just water, with a little bit of actual waste mixed in. Trying to transport and treat all that water is a huge waste of energy and money. So really, the entire story of sludge treatment is about one thing: getting the water out. Okay, so how do you even begin to get all that water out? Well, you start with the most logical first step. You do an initial simple squeeze to get rid of the easy stuff and just slash the total volume you have to deal with. And this is all about efficiency. I mean, think about it. Every single gallon of water you can remove right here in this thickening stage is a gallon you don't have to pump or process in the more expensive, more complicated stages down the line. It's all about making the rest of the journey way more manageable. And the simplest way to do this? Just use gravity. It's kind of like if you let a really watery stew just sit for a while. All the heavy stuff sinks to the bottom, right? Same idea here. They let the sludge sit in big tanks, gravity pulls the solids down, and then they can just drain the clearer water off the top. It's low-tech, but it works wonders for cutting down the volume. Okay, so we've gotten rid of a lot of the water. The sludge is a bit thicker. Now it's time for the really cool part. We're going to fundamentally change what the sludge is. And to do that, we bring in the real heroes of the treatment plant, the microbes. Sludge digestion is basically just controlled decomposition. We're creating the perfect little world for tiny microorganisms to eat up all the organic stuff in the sludge. And this does a few amazing things all at once. It actually reduces the total amount of solids, it makes the sludge way less stinky and more stable, and, this is a big one, it kills off harmful pathogens, making the final product a whole lot safer. Now, there are two main ways to set up this microbial feast. On one hand, you have aerobic digestion, which uses oxygen, kind of like a compost pile. It's pretty fast, but you have to spend energy pumping air into it. On the other hand, you have anaerobic digestion, which happens in a sealed tank with zero oxygen. Now, this way is slower, but it has an incredible bonus. The microbes actually produce methane gas, or biogas, which can be captured and used to help power the whole plant. It's a total win-win. And that anaerobic process, it's actually a delicate two-step dance. First, you have one group of bacteria, the acid formers, that break down all the complex gunk into simpler organic acids. Then, a whole different crew of microbes, the methane formers, come in and eat those acids, producing that valuable biogas as a result. The whole trick is keeping both of these teams happy and working together in perfect balance. Now, this table might look a bit technical, but it shows how engineers can supercharge that process. Look at the standard rate column. That's the simple approach. Just let the sludge sit for a month or two. But check out the high rate column. This is the advanced version. By heating and mixing the sludge, you can feed it way more material every day, that's the solids loving, and get the job done in just a couple of weeks. You end up with a better result, faster. It's a classic engineering trade-off. Spend more money up front on tech for way better efficiency later. Okay, we've reduced the volume, we've stabilized the material. Now it is time for the final, heavy-duty squeeze to get out as much water as we possibly can. Welcome to the dewatering phase. After this step, the stuff we're dealing with isn't a liquid anymore. Not even close. It's a damp, soil-like material that you could literally pick up with a shovel. This end product is sometimes called sludge cake, but more and more we call it biosolids, and that name hints at its amazing potential. Engineers have a whole toolbox for this final squeeze. The methods range from the super simple, like sludge drying beds that literally just use the sun and air, to some really high-tech machinery, like filters that use incredible pressure to physically force the water out. Sometimes they even add chemicals to help the solids clump together, which makes separating them from the water even easier. And this slide really nails the decision-making process here. It's all about trade-offs. Let's say your treatment plant is in a place with tons of cheap land and a hot, sunny climate. Well, sludge drying beds are a no-brainer. They're cheap and effective. But what if you're in a crowded city where it rains all the time? Then you've got to invest in those expensive mechanical systems that can run 24/7 in a small building, no matter what the weather is doing outside. So, we've thickened it, we've digested it, and we've dewatered it. We are officially left with a pile of biosolids. The journey is almost over. But the big question remains. What do we do with it now? Where does it go? At the end of the day, there are really three main paths this stuff can take. The simplest option is to just bury it in a landfill, but that's not very sustainable. You could also incinerate it, which reduces the volume down to a sterile ash, but that can come with its own set of concerns. Or you can put it to good use. And this is the most exciting outcome by far. It turns out that these biosolids are packed with valuable nutrients like nitrogen and phosphorus. Once they're treated to make sure they're safe, they can be used as an amazing fertilizer and soil conditioner on farms or to help restore damaged land. This is the moment a waste product truly becomes a resource. It's the ultimate recycling story. This chart just sums up the entire journey perfectly. Take a look at the bar on the left. That's our raw sludge. See how almost all of it is just water? Now look over at the dewatered biosolids on the right. The water is way, way down, and the solids are now what it's mostly made of. Every single step we just talked about was designed to make that one transformation happen. You know, this quote really captures the whole philosophy. Environmental engineering doesn't make waste just disappear. What it does is intelligently transform it. In this case, it takes a watery, potentially hazardous problem and turns it into a stable, manageable solid that we can either safely contain or, even better, put to good use. Which really brings us back to the big question, doesn't it? After seeing this entire journey, is sludge a waste or is it a resource? And the answer, as we've seen, really depends on how we decide to look at it and how we choose to treat it. With smart engineering, we can transform what starts as a problem into something incredibly valuable, turning the end of one cycle into the beginning of a whole new one.